Hi folks, thanks G, that's great, and welcome to the virtual big day in today. I'm the first up, so hopefully you can see my slides and you can see me and everything's all good to go. So welcome today. I'm going to talk to you about these engines of the future and the things you need to be thinking about and what you can do to get ahead with technology. So let's move. What I want to start is tell you a story. Okay, the story is going to be about something which isn't related to technology. It's related to farming ice. Years ago, when you needed to get ice and you needed to put food and make it cold, there was ice farms, and you had to wait till winter time and store lots and lots of ice, and lakes freeze, and they actually had to store lots of ice, cut it up, and then actually they made a big booming trade out of that. Now, you're thinking, why am I talking to you today about ice farming? Well, what happened then was actually they thought, well, how can we make this better? How can we innovate? And the idea of innovating was then to actually start to produce ice all year round, creating their own warehouses to store ice, and even trying to get horses, like you can see in this picture, to actually drive the actual ice to wherever they needed to go. What innovation they thought that was. Now, they would move in and accelerate in slightly, but actually they weren't jumping the curve. If you think forward to where we are now, we're thinking about actually people creating their own ice, right? And that's what I mean by the head on the side, you're jumping the curve. It's very, very important that you're thinking about the next thing. Now, when it's hard in technology, you might be thinking, well, I'd like to be the next games designer, or I'd like to be the next, Netflix engineer, for example. But true innovation happens when you jump the curve. You actually see what's coming and develop for that. So what we're going to do today is look for some of those things that are happening now and what you can think about for the future. So from a Microsoft point of view, and from a general industry point of view, these are some of the three key drivers that you should start thinking about. Okay, there are lots more drivers and trends depending on who you're talking to, but this is where generally technology is going. The cloud, right? And we'll look at that in a little bit more detail in a second, but it's very, very important to start to think about, well, okay, what is cloud? Do I understand what cloud is? Is it a skill that I've got? Because at the end of the day, you hear a lot of terminology, when we're talking about big data, artificial intelligence, and machine learning and the like. There's a lot of terminology around there, but actually we need to start thinking about what that is. And sometimes it isn't rocket science, okay? And even rocket science isn't even that complicated. But you've got to think about what these technologies are, and we'll look at that in a second. But when we're talking about cloud, one of the trends is around big data. So we're collecting data in from more and more sources all the time. When you look at some of the technologies that have recently happened, Tesla cars, for example, autonomous vehicles, that's all because of big data and using cognitive services and visual APIs to be able to recognize objects in the road, to recognize speeds, to know where the car is, and actually process that very, very quickly. You think about things like rockets. In the last couple of weeks on Earth, we've seen a couple of amazing things where people have got up to space, and a lot of that is possible because of big data. And also AI. Some of these rockets now are landing on drone boats, for example, on drone ships, and landing upright in the middle of the desert. And that's down to AI and actually understanding and doing that machine learning on board and doing that computation really, really quickly. So cloud, very, very important. Big data and AI, big drivers for you. Then the middle one, security and privacy. We've seen a lot of ransomware attacks recently. We've seen a lot of state actors kind of infiltrate in different systems in different countries. And people are more and more care about the security and the privacy of what they're actually doing. And then on top of that, you then think about even levers that are pushing the boundaries even more, including quantum computing, which we'll talk about a little bit today as well. So these are key drivers, right? And really, really important. And when you start to put them all together, it becomes really interesting. So when you're thinking about big data, for example, and then privacy, it's great to actually have some analytics happening. For example, it's great to say, give the police information real time about criminals and crime that's happening. But then you've got ethical and privacy issues you need to think about. Is it right that you should be using facial recognition, for example, in stores and things to cross-check criminal behaviors or whatever it might be? So there's an ethical issue connected into that. And then breaking that apart, like I said about quantum computing, that's really going to push the boundaries even further than where we are now. So this is another interesting element. These are some real case studies that are happening now, right? So to kind of bring those three drivers and those technological engines to life, let's talk about three areas, but actually bring it into reality, right? That's happening in Australia. So this is a project here about Darwin Harbour on the top left, right? Feel free to put this into your favorite search engine and search some of these case studies up. They're all online, and there's some great videos to go with them. But in the harbour in Darwin, you can't actually go into the sea because of the fact that there's crocodiles in there, all right? So we need to count fish stocks. So we've got drones and cameras underwater which count fish, okay? And they know what types of fish based on visual APIs. Second case study here, we teamed up with indigenous traditional owners in Kakadu, and we use AI and drones, so visual recognition again and facial recognition, to rehabilitate parts of the national park there. So actually we can go across wetlands with the drones and actually use AI to keep track of native species of magpie geese, which have a big indicator for the actual health of the environment as well in that region of Australia. This is another interesting one. We're using cloud and AI to actually monitor turtle nests. We're seeing up in some of the really remote areas in Western Cape York, which is really far up in North Queensland, the feral pigs are eating a lot of the turtle eggs. And it's kind of pushing the turtle population into decline. So we are using drones again to actually, and video footage and camera technology to actually analyze those for feral pigs and then identify and protect where some of those nests might be. New South Wales Police. We're doing a lot with New South Wales Police. Some we can't really talk about on this call here, but because some of it's quite new and hasn't been finished yet, but we're doing a lot of things around connection to actually really try to tie things together in terms of criminal behavior, right? So it's often about correlating data. And when I talked about big data earlier on, this is where this comes into its own, right? Because it might be that when you're thinking about a criminal, there might be one small piece of evidence and you've got to gather that. And detectives over history have actually had to gather that, create evidence files. You've seen it on TV and things. But now more often, it's digital data. So mobile phone data, social media data, Instagram posts, TikTok posts, when you're online, your location services, where your images have been taken, where your text messages have been rooted in the back end in the systems, what cell towers you're near, and they've been able to solve murders and really serious crimes via correlating. That means connecting the dots between data together. So a lot of that big data stuff with the police is fantastic. And then some other things around the NRL, for example. We've digitized a whole heap of that content to actually augment the drills which happened in the past to really enhance fans' experience of the game. And we've done a lot with, say, Barcelona Football Club as well in Europe, or soccer club, so that you can actually really bring some of that to life with the fans. So then another one is New South Wales Health. So actually for the New South Wales Health itself, the pathology, we're actually trying to transform medical testing. So we're using cloud. So we're putting that data into cloud and AI with the AI technology to actually start to look for new drugs, to support speedy data to the patient so that you're going to have patient care much more quickly. So there's a lot of stuff happening now, and that all connects to data and AI, the cloud, And also you can see where security and privacy starts to connect in the dots as well, right? When we look at a lot of these things. So what is this cloud, you say? Well, the cloud is essentially being able to put servers and services into companies' data centers. So this is some Microsoft data centers. This is our cloud. And, you know, it isn't in the cloud, you know, it's called the cloud, but it's essentially moving your stuff off premises and allowing you to actually network, you know, multiple thousands and thousands and thousands of computers together, so you can get access to really high speed, high performance compute very, very quickly. Okay, so really, really interesting, really, really worth thinking about, because, you know, schools and universities struggling to keep up with lots of the technology. You know, there's only a couple of companies inventing this stuff, which Microsoft is one, and that's allowing people to disrupt, like Netflix, like Uber, like Disney Plus. They're all disrupting their industries in different ways. Now, and that's why it's important to jump your curve, as I said, because what we've done with Microsoft and Xbox, for example, you think about the console wars, really they're over now. Okay, you know, the best console is the one you're playing at the minute, right? So I'm not going to get into the PlayStation versus Xbox debate, but the console wars are over, and I'll tell you why. Because when you think about it, you know, every year, every 2 years, you have to buy a next generation console, and it's, you know, more speed, higher GPU, you know, all of this kind of stuff, better graphics. You have to buy the hardware. What if you could spin up that hardware, and the latest hardware, even if it comes out like next week, you could spin that up and be super quick, you know, and get that running in real time in the cloud, in Microsoft's data centers. You can spin that up immediately. You don't need to go to the shop and buy it. Well, that's what we promised him with xCloud, right? And what that means is that you don't necessarily need an Xbox console to play Xbox games. You can play Xbox quality games on an Xbox console or even a quantum computer inside our data centers. So let me give you an example of why that's interesting. So this is Microsoft Flight Simulator. This game has got real-time data in it from the geography of the world, right? So you've got real-time weather systems, real-time kind of cities, real-time objects in the world as well. So, for example, there was a ship that got stuck in the Suez Canal that even ended up inside Microsoft Flight Simulator. So that's a really interesting first foray into using real-time geographical information system data and games. Okay, so the cloud is here to stay, and it's impacting the games industry massively. Now, this video may lose some audio here, so I'm going to talk you through it if you can't hear the audio. Okay, essentially what we've got is also holographic computing. Okay, now what you're looking at here is a Microsoft HoloLens, right? Now these are really interesting pieces of technology that actually Windows 10 / Windows 11 computers. Now we use some of that background sound, so leave it run. If you've got a Windows 10 laptop in front of you, or even thinking about a Windows 11 laptop, you can start to think about using mixed reality already. You've got mixed reality in there. You've got Pink 3D to allow you to do those things. But we are seeing some amazing advances around that mixed reality area as well, which kind of connects in with big data, and it connects in with our next topic as well, which is quantum computing. So our next trend that we're really thinking about. So quantum computing, what is that about then, Dan? Well, let me tell you. Traditional computers use binary, ones and zeros, okay? Quantum computers can actually be in two states at the same time. They can be 0 and 1 simultaneously, and that's what we call a qubit. Now, that might sound a little bit kind of far-fetched and a bit odd, right? So let me give you a quick example here, right? There's a thought experiment in quantum physics, which is by a guy called Schrodinger. And what this is his famous problem, a thought experiment called Schrodinger's cat, right? And the idea is you put the cat inside a box. It sounds a bit gross. And then you put a vial of poison in there, and then the cat could knock it over or not, essentially. So the cat could be alive or it could be dead inside if it knocks the poison vial over and breathes in the fumes. So the thought experiment is only when you open the box do you know what's happened to the cat. Okay, so that means the cat inside the box, when you're not looking at it, is alive and dead. So there's essentially two cats in there. Think about that for a second. Look on YouTube. There's some really good explainers on there. But that essentially means you can do two things at the same time, right? Now, if you look at this diagram here, now let me see if my Microsoft Surface Pen will work. If I was using classical computing, right? It isn't going to work. If I was going to use classical computing, I could, to find that light bulb in the middle, I'd have to follow it through from each pathway all the way around there to find that light bulb in the middle. So I'd have to check, you know, one pathway, another pathway, 3 pathways, 4, 5, 6, 7, 8, 9, 10, 11, 12, keep going around, you know, and it takes a while, as you can see, right? And that's quite a simple problem. What quantum therefore means is that you can do all of those simultaneously. So to find that actual light bulb, you can see the pathway happen immediately. So that means the speed of computing is going to be exponential, right? Which has got an amazing kind of input for the rest of the world for what they are doing. Okay, so if you can use a quantum computer like we are developing in Sydney, in the Microsoft labs in the University of Sydney there, if you can actually run your algorithms on a quantum computer, then you can solve things so much more quickly. It's also going to create problems with things like encryption, because encryption is going to be easy to crack as well. Whereas previously it might have taken thousands of years to crack, you know, 64-bit encryption, for example, it might take a fraction of a second. So we have to think about how we're going to be securing things, how we're going to be using these technologies, and actually what engine that is going to bring, what things that haven't even been invented yet can be done by quantum computing. So let's watch this video.
Talk about quantum computing, it's a completely different game.
Quantum computing will enable us to solve problems that currently take longer than the lifetime of the universe in seconds, hours, or days.
We completely reconceive the space in which we do computation.
Quantum computing is like going from crawling to going to a different planet. It's different.
It's only natural that we would want to use the world's most powerful device to combat the world's most challenging problems.
We could attack global warming.
Security.
What are the boundaries of machine learning?
Fighting diseases. The possibilities of quantum computers are endless. Microsoft has the best and the brightest working on this problem.
It's really happening. Progress is very fast, and we're building a quantum computer.
What the world wants to know is what happens when we turn the machine off.
What problems will be solvable with a computer that computes in a billion parallel universes at the same time?
So that's pretty mind-blowing stuff, eh? So to bring things together, you've seen the engines that I'm kind of calling out as the future here. Where do you start? Okay, there's lots of options to you. Okay, you can't go wrong with this, as the little quote says here from Alice in Wonderland. You know, but it's worth thinking about these things. If you don't know what's coming up and you've got ideas about it, then there's no pathway for you. So you've got to think about your pathway, but don't worry, because these little changes you're going through, it's changing for my career, it's changing for everybody listening, even your teachers, for example. Their pathways have changed throughout their lives, and this happens. Life throws that at us. So more so than ever, it's important. The learning is the key. So you can go to some of our websites, Microsoft Learn, for example. If you just put that into your favorite search engine, okay, you can reach out to your schools would have Microsoft teams working with them. We've got lots of skilling programs we're doing for schools, like our Imagine Cap Junior, which is about AI for good, for example. So you can reach out to the Microsoft teams that are working with you. We have Minecraft competitions, which might sound a bit silly, but actually at the end of the day, that does focus on real technologies. But all of this stuff is online on our Microsoft Learn platform. Okay, and it's important to start thinking about, you know, getting those qualifications, because you're not going to get them at school, because we're inventing them now, right? We're inventing tools and technologies today that are, you know, and tomorrow and the next day that you know, schools and universities can't even keep up with. So it's important you stay on top of your own learning. So to bring things together, I think it's important to think about those engines. You know, when we talked about data, we talked about security, privacy, we talked about quantum, you know, and all of the things in between. You've got technologies like blockchain and mixed reality and Hololens, like we looked at, and a whole heap of things. But ultimately, there's a lot available to you, and we need you, and we need engineers and people who think creatively to come up with the problems and solve the problems with the future, with the technologies that we develop in. Okay, so the last comment here is, you are the future, and it is yours to make. So hopefully that's been really useful for you today. It's given you some inspiration, and happy now to take some Q&A.
Thanks, Dan. We have a few questions for you today.
Okay.
The first question is, what are the areas with more job opportunities in Microsoft Australia?
Okay, Microsoft Australia, you're going to think about technology companies, and these are lots of them, okay? Microsoft's a platform company, right? So that means people make money building stuff on the Microsoft platform. That's one reason that I like working for Microsoft, is because we generate the platform and people make software for it. So you think about Adobe, for example, they wouldn't exist without Microsoft, right? Lots of the tools and technologies run on the Microsoft platform, right? Which gets it out to the majority of users out there. You've also got the Mac operating system as well. So think about it, that it's not only Microsoft you're concentrating on, but there are 10,000 of our partner organizations across Australia, which you're going to hear from today as well. They use Microsoft technology to build on, right? So they build their platform and they billions of dollars on top of our Microsoft operating system. So the second thing is, Microsoft as well is a company that has a whole range of people. So we've got a doctor working for us. We've got several doctors working for us because they work in our health industry. I'm an ex-teacher. I work in the education industry, right? We've got people who are police people, for example. We've got lawyers. We've got marketing people. So all the videos you see, those sizzle videos you saw earlier on, are by some really talented marketing people in Microsoft. So everybody on the call here, whether they technologically focused or not, you know, an organization will have a legal team, a finance team, a marketing team. So Microsoft Australia have got jobs in every field. If you're looking though for that technology field, we've got lots and lots of jobs around data and AI, around infrastructure. around app development and modernizing, so supporting people, so customers who are struggling to move to the cloud, like one of those engines I showed there. So there's a lot of jobs to help customers move to the cloud and think strategically. So my job's called a technology strategist. So what I do is I go into my customers and I speak to them about what's happening in 5 years' time and how they actually can get on that journey. So there's a lot of jobs. Go onto the website, have a look at the careers. I think it's careers.microsoft.com, and have a look and see what's there. But you'll notice that a lot of them are jobs for the future. Data and AI, machine learning, cloud, big time security will be in there. So lots of the things related to the tools we talked about today. Long answer, but lots of jobs in technology in Australia.
Thank you. We have another question for you. What do you think will happen to the world if we fully figure out quantum computing?
Oh, that's a game changer, and you know, it boggles my mind to even think about it. I think once we are close to getting that sorted, you know, there's 2 or 3 companies working on the quantum computers now, and some are in production. You can already start coding for it, but the result of it is going to create some amazing opportunities and also going to create a lot of threats as well. We need to govern it very, very heavily, because security is my worry. It's going to blow security out. So your banking, your online presences, you know, all your encryption is going to be at risk. So what we're trying to do is put a lot of effort into the supportive use of quantum, so the use cases to help quantum do things for good, and actually put some use cases in place to tighten up some of the things where it could start to be used for not so good purposes. So, you know, I think we're going to solve a lot of problems with quantum. We're going to be able to crack things much more quickly, especially things relating to the climate, where there's a lot of data. We can crunch that data, you know, very quickly. Currently, universities use supercomputers for that, or they hire Azure Space, which is our cloud, to actually do high performance computing calculations around the cosmos and around nature, because there's a lot of data points. So we're going to be able to resolve a lot of those questions really quickly. So a lot of modeling, which we do, will be able to resolve quickly. So I think it'll hopefully really help us combat climate change, but also on the other side, we've got to be really careful about the misuse of quantum, if that makes sense.
Yeah. I think we just have time for one final question. Does Microsoft provide internships or work experience for high school students?
We don't technically, but our partners do. We do have internships, so they're usually focused on university internships, and we have a big program of protege. I do lots of interviews for that. So there's a program of interviews that happen from university grads. In terms of high school students, you know, you can ask your teachers, and we can set something up, and you can come along to Microsoft and come to our offices. We've got an office in each state, and we can talk to you about jobs and stuff, and you know, there's things you can do locally with some of our employees to help you, but there's not a formal program as such in place. But yeah, go onto our website, reach out to your local team. You can always email me or find me on Twitter. You can see it on the bottom there, and then see if we can accommodate like a class of students to come to Microsoft and have a look around or whatever. Some students in Australia have even gone to Redmond, our mothership campus over there, before COVID, and looked around and spent some time in Silicon Valley in various tech companies. So reach out to us for more info.
Yeah. Thank you, Dan. Thanks, Dan. No worries.
Thank you so much.
Thanks, Dan, for your insights and sharing your experience about IT careers.